Hello everyone. Today we're going to study the methods of forecasting. This is the part 9 of energy economics. The first method that we'll be looking at today is called as a reference method. First, let me start with an example so that we understand this method better. So let's take an example. We want to calculate the heat or let's say the electricity demand. We want to calculate the electricity demand. Let me write it as E. The electricity demand on Tuesday. We want to calculate the electricity demand on a Tuesday. We want to calculate the electricity demand on a Tuesday with a mean predicted temperature. With a mean predicted temperature of 10 degree. With a predicted temperature of 10 degree. So this is our aim. Okay, our aim is to calculate how much electricity should be generated for a Tuesday with a mean predicted temperature of 10 degree Celsius. For this to achieve this particular thing, what we do, we simply refer to the historical database and try to find one more Tuesday. We try to find another Tuesday in which we have used 10 degrees Celsius, in which the temperature was 10 degrees Celsius, or it is close to 10 degrees Celsius. So what we're doing, we are going to our historical database and we're trying to find out another Tuesday. We're trying to find out another Tuesday on which this particular incident has happened. That is, we have utilized 10 degree Celsius. Energy temperature was, the mean temperature was 10 degree. Like that situation, we have to look at in our database. So once you find out, then that is called as a reference method. That is called as a reference method. If by chance we do not have a 10 degree on a Tuesday, when we're referring to historical data, if we do not find this particular scenario that we're looking at, then we'll try to find another data that is close to 10 degrees Celsius. This is called as reference data. It's called reference data. This method works without a mathematical model. The pure form of this method, the pure form of reference method, works without a mathematical model, because in this we're just referring to the past data. Because in this we're just referring to the past data and then predicting or forecasting. That's why it is not using a mathematical model, but in today's world, reference method is used along with regression model or other models. And this method intends to find a situation in the database or the historical data which is similar to the one which has to be predicted. This method is intending to find a situation in the database of the historical data that is similar to one which has to be predicted. So what we wanted to predict here, this is what we wanted to predict. So we went and we found a similar situation in our historical database. So that is the intention of this method, to find a situation that is similar to the database, that's similar to what we have predicted in the historical database. That's what this method is all about. The merits of this method is very simple to implement. The results can be easily implemented. The demerits of this method is, if there are more criterias, then it will get complicated and it will be tough to use this method. Here the criterias were less. In this the criterias were less. So we went to the past data and we found out the exact match and we came. But if you put on more criterias, this method is going to turn out to be really tough. So that is the disadvantage of using this method. Now let's understand what is time series analysis. This model is a non-causal model of demand forecasting. So this model, time series analysis model, it helps us in demand forecasting. Demand forecasting of what? We can take the example of energy. It helps us to forecast the demand of energy, and it is a non-causal model. What do you mean by a non-causal model? Non-causal model is there's no cause and effect relationship established in this model. In case of causal models, there's a there's an relationship of cause and effect that is established, but in non-causal models, no such relationship between the variables is established, and this is not established, and is used for demand forecasting. So this is a non-causal model that's used for demand forecasting. The variables that are predicted under this model are expressed as a function of time. The variables that is expressed in this model, whichever variable is used, it is expressed as a function of time. Thus, the other factors which influence the variables are neglected. See, these variables are not just impacted by time, variables can be impacted by a lot of other factors. But in this particular analysis called time series analysis, only one factor is considered, that is time. So we're assuming that time only is impacting the variables and no other factors are having any influence on the variables. A time series data is often a superposition of the following: long-term trend variation, cyclical variation, seasonal variation, and irregular variation. The merits of this method is it is simple and it is easy to use. The demerits of this method is it is assumed that the pattern of the past will continue in the future. In this particular method, we are having this assumption that whatever has happened in the past, based on that, we are predicting something under this method. We are predicting the demand. We're forecasting the demand based on the past records that we are having. So there's an assumption that the pattern of the past will continue in the future. So that is one demerit. The second demerit is that it ignores the interaction of the variables. It ignores that the variables are interacting. That factor has been completely ignored. And it even ignores that the other factors also influence the variables, and it is not just time that is influencing the variables. There are other factors also as influencing the variables. So this is time series analysis. Now the third one is regression model. Regression models describe the causal relationship between the input variables and the desired output by the use of either linear or non-linear functions. The shape of the straight line is determined by the regression parameters. The shape of the straight line is determined by the regression parameters. The conclusion of the regression analysis has to be proved with regression diagnostic. Regression diagnostics involves the following questions. Does a linear relationship between the input variables and the output variable exist? Which input variables are really relevant? Is the basic data set or measurements consistent, or are they not consistent? So these all questions need to be answered under regression diagnostic. The fourth method is the artificial neural network. Neural networks represent adaptive systems that describe the relationship between the input and the output variables without any explicit model functions. So what are neural networks? Neural networks are the networks that are representing certain adaptive systems that describe the relationship between input variables and output variables, and there is no explicit model functions involved. Neurons are the basic elements of the neural networks which are linked to each other. So neurons are the basic element of the neural network. And these neurons are of three types: input neurons, output neurons, and the hidden neurons. Neuron topology is the pattern of connection between the neurons. So the pattern in which these neurons, which are the basic elements of the neural networks, that is neurons. So it is the pattern. Neural topology is the pattern of connection between the neurons. So the way in which these neurons are connected to each other is referred to as a neuron topology. Is referred to as a neuron topology. The computed time. These 2 points represent the demerits of the artificial neural network. The first demerit is the computing time taken by the neural networks is more. So the neural networks, the computing time they take is more. And on top of that, the bigger disadvantage is it's very tough to interpret the results of the modeling. So this is also another demerit of the artificial neural network. Thank you so much for watching the video. Please do like and subscribe. Thank you.